This is day 19 of Unit 4. We started today with a warm-up. These two problems are referring to material that was taught right before break. So go back and watch that video if you were absent for that. The first one is finding the distance between 0, 0 and this point on the complex plane. So we do that using the Pythagorean theorem. The equation that was taught was the absolute value of a plus bi is equal to the square root of a squared plus b squared. So I'm using the square root of a squared plus b squared. So the square root of 4 squared plus the quantity negative 6 squared gives me the square root of 16 plus 36, which is the square root of 52. And 4 times 13 is 52. So 2 times the square root of 13 equals 52. So 2 root 13 is equal to, is my answer, the absolute value of 4 minus 6i. The other one is simply just referring to the complex plane, which I briefly talked about before break. The real part is along what we're used to as the x-axis, and the imaginary part is along what we're used to as the y. So the 4 minus 6i would just be the coordinate point 4, negative 6. That point right there would be 4 minus 6i on the complex plane. Okay, so today we revisited some application problems that we had done before break. This time, though, we used the graphing calculator. So in your notes, go ahead and put this equation. And the very first thing we did was just enter that equation into the graphing calculator. So I'm going to do that. While you follow along with me here. Okay, so I'm going to go to y equals, which is this button here, and then I'm going to type my equation in. So my equation is negative 100. For the negative, I use this button, not the minus sign. 100 x squared. To get the x, I use this button here. And then squared, I use this button. And then plus 350. And then x, so again, this button. And then minus 25/4. So I'm going to type minus parentheses 25 divided by 4. And then enter. Now, if you have an Inspire, you're going to go to the graphing screen, and immediately when you get to the graphing screen, you'll see there's a top place at the top that you can enter the equation in, which is what we've just done. And your x is just a button that has x. So we have it entered. Now, normally the graph is set, or the window is set to show the standard viewing window, which the standard viewing window, I'm not sure if mine's set on that now, but the standard viewing window is negative 10 to 10. And going up by ones for the x-axis, and then negative 10 to 10 going up by ones for the y-axis. So if I look at that window and graph it, I'm getting what looks like a vertical line, although I know based on the equation I typed, again, let's look back at that, I know it should be an upside down parabola. So because I'm not seeing that, what it's telling me is I'm going to have to change my window from the standard negative 10 to 10 to something else so that I can see the full parabola and not just what looks like a vertical line. So because it looks like a vertical line, in addition to looking at the equation and seeing that we have numbers that are in the hundreds, I'm guessing I'm probably going to have to adjust the y values to make them go higher than just positive 10 for my y max. So that's the first thing I'm going to do. So I'm going to go back to window by touching window. On the Inspire, you would do menu and then window settings, you'll see there. And then I'm going to keep the x's as they are, but I'm going to make the y maximum, I'm going to try something in the hundreds. I'm going to try 300 and enter. Now this is a little bit of trial and error. I don't necessarily know exactly what to set it at, but I do know if I'm going from -10 to 100, I probably want to scale that by tens rather than by ones. So enter, and I'm going to graph. Now my goal is to see the entire parabola on the screen, which I can now see. Okay, I can see the whole thing. So once you have the whole parabola on the screen, then you have the window set appropriately. If I was still unable to see the whole parabola, then I would go back to my window and I would again adjust either the x min or max, the y min or max until I can see the whole graph on my screen. So now that I have that graph, I'm going to go back to my question, which is find the daily profit for selling the bread at $2 per loaf. So if you recall this problem, X is the dollars of a price of one loaf of bread, and Y or H was the profit. So if this question is asking us to find the profit for selling the bread at $2, that means, if you recall, that we need to substitute 2 in for X. And when we did this by hand, that's exactly what we did. We substituted 2 everywhere there was an X, and we figured out the Y value. So on the calculator, there's a way that I can do that as well. So what I can do is on my graphing screen, this button here that says trace, right above it, it says calculate. Most of what we do today is going to be located there. So I'm going to do second, and then that trace button, which takes me to this screen, and I want to calculate the value, meaning I want to know what the Y value is when I specify an X value. So as 1 is highlighted, I'm going to hit enter. And now it's allowing me to enter in an X value. So I want to know when X is 2. So I'm going to enter 2. And it tells me that when X is 2, 293.75 is my answer. So I'm going to go back here. $293.75. Okay. So you can see it's a lot easier using the graphing calculator. So the next question, what price should the bakery charge in order to maximize its profit, and see what is the maximum profit? Both of those questions, if you recall, I'm looking at just a quick sketch of my graph, both of those questions are referring to the vertex. That's going to be where the maximum profit is and what the price that they should charge to get that maximum profit. So remember, by hand, we completed the square to get the equation into vertex form. So we knew what the vertex was. Here, we're going to again use the graphing calculator feature that's going to show us how to get the vertex, or that's going to get the vertex for us. So back to my calculator. Once again, I'm going to do second and then the trace button, so the calculate screen. This time, though, I want the maximum because the vertex is the highest point on the parabola. If this had been a right side up parabola, I would be using minimum, but it's the maximum. So I'm going to hit number 4 for maximum. Now, it's saying left bound question mark. And so what I want to do is I need to move the cursor from where it currently is. I need to move it so that it's just a little bit to the left of the vertex. So I'm going to use my left arrow so that it moves over. Notice as I'm pushing the left arrow, it's going over to the left. And now I'm going to hit enter because it's to the left of the vertex. Now it says right bound, so I'm going to go to the right of the vertex. So I'm using the right arrow just a few times. I can see it's to the right now, and I'm hitting enter. Then guess, I'm going to try and get it just about on the vertex. It doesn't have to be perfect, but it has to be close. So it looks like it's about on the vertex, so I hit enter a third time. It's telling me 1.75 approximately and 300, which means, remember, X is our price and our Y is our profit. So $1.75 will give the highest profit of $300. And I was able to find that vertex without doing any algebra, any completing the square there. So we would say $1.75 and $300. Okay, so again, that was using the calculate maximum feature. Okay, so now let's try this equation. We also did this one previously. We have this catapult. So I'm going to go ahead and enter that equation into my y equals in the calculator. So I'm going to go back to y equals, and I'm going to clear that. That's the easiest way. Just clear it and write the next equation. So we have negative 0.00125. We have x squared plus 0.5 x plus 200. And enter. So I'll check the window that I currently have it set at by hitting graph. And this time it's looking like a horizontal line. And once again, looking at the equation, negative 0.00125x squared, I know it should be a negative orientation, upside down parabola. So last time, if you recall, the graph looked like a vertical line and we adjusted the y to make it look like the parabola that it is. This time it looks like a horizontal line. So I'm guessing I probably want to adjust my x values so that I can see more of them. Because what's happening is it's so zoomed in here, we're just seeing a small portion of the parabola and we're not seeing enough of the x values. So I'm going to go to my window and I'm going to adjust the x maximum to something. Now again, I don't really know how much I'm adjusting it, but I'm guessing based on these numbers, this 200 on the end, I'm guessing I probably want something at least 200. So I'm going to make my x max 200 and I'm going to go by tens. Enter, and now I'm going to graph. So I'm seeing it's looking a little bit better. It's looking more like a curve now, but I can't really see this left side. And I can't really see, I can tell there's more of the parabola on the right. So I'm going to adjust both the x-min and x-max so that I can see more of the graph. So I'm going to look at like negative 200 maybe. And I'm going to look at maybe 500. And by tens should be fine. So let me graph that. Looking better, but I still can't see all of the parabola. So I'm going to make my x-min something a little bit smaller, my x-max something a little bit bigger. So maybe negative 300. And let's try 800. And now I'm going to graph it. Okay, that's looking about perfect. So again, I just kind of played around, adjusted till I can get the right picture. Now I see the full graph. So now I'm able to answer the questions. So the first one, what is the height of the fireball just as it is released? Well, remember, x is the horizontal distance in feet from the point it is released. So in other words, we want to know the y value when the x value is 0 because it's 0 away from where it's released when it's released. So this one might be easy enough that I can just look at the equation because it's in standard form and realize it's going to be 200 when I substitute 0 in for x. And these are feet. Or if I want to use the calculator, I can. Remember, we're going to calculate the value when x is 0. So second, calculate value is number 1, and then 0. Enter, and it's telling us 0, 200. So that's the other way to do it. Next question. What is the highest wall the fireball can clear? And see how far from the catapult does the fireball reach its greatest height? So we know that both of those are referring to the vertex. So I'm going to have to find the vertex. So let me use the calculator to do that rather than completing the square by hand. So I have the vertex visible on my screen, which means I can use the calculate feature. I want the maximum again because this is the highest point, so that's 4. Left bound, I'm going to use my arrow so that it's just a little bit to the left of the vertex and hit enter. Use my arrow again to make it just a little to the right of the vertex and enter. And then try and get it on the vertex and enter. And it's telling me about 200, 250 is the vertex. So back to the question. What is the highest wall the fireball can clear? That's the height. So that's the y part of the vertex, which is 250 feet. And how far from the catapult does the fireball reach its greatest height? That's the x part of the vertex, which is 200 feet. Last question, what is the maximum distance it can be launched? Well, if you remember when we did this in class, there's my sketch. This is the point I'm looking for right there. That's the maximum distance it can be launched. So that point is the x-intercept, which means the y value is 0. So I'm looking for the x value that makes the y value 0. So the x-intercept, there's a way to get that on the calculator. Another name for x-intercept is called a 0. Okay, so I'm going to once again go to my calculator and go to second trace button, the calculate feature, and I want this time number 2, which is 0, 2. So it's going to be similar to what it did a minute ago when we were trying to find the vertex. Remember, it was left bound. We went to the left. The left of the vertex, we hit enter. We went to the right of the vertex, we hit enter. We went on the vertex, we hit enter. This time, though, left bound, right bound, and guess are going to be in reference to the x-intercept, this one here. That's the one we want. So we're going to go to the left of the x-intercept, to the right of the x-intercept, and on it, which in this case, to the left would be a little bit above the x-intercept, to the right would be a little bit below the x-intercept, and then on the x-intercept. So I did second calculate, I did 0. Now I'm going to go with my right arrow down a good bit here, so I'm just going to keep hitting it. So that it's just to the left or above the x-axis. Enter. Right bound, I'm going to keep going until I can't see it anymore, because that means it's now below the x-axis, or I can see the y value is now negative. So that means it's to the right of the x-intercept. So enter. Now I'm going to use my left arrow to bring it back up so that it's on, or really close to being on. There we go. The x-axis, and now enter. And it's telling me 647.21 is the x-intercept. So back to my question. 647.21 approximately feet is the maximum distance that it can be launched. Whoops, sorry about that. So that's my answer for D. Okay, so that takes care of our questions today. Really, I just wanted you to know how to use the calculate features on the calculator. So the 3 that we talked about are finding the y value when the x value is something. So y equals when we put in an x value, and that was in the calculate screen, that was calculate value. The second thing we looked at was finding the vertex, and that's calculate in the calculate menu, either minimum if it's a right side up parabola or maximum if it's an upside down parabola. And the last thing we talked about was finding the x-intercept. And the way we did that was by doing calculate and 0. Another name for an x-intercept is a 0. And for both the minimum maximum, which is the vertex, and the 0, remember we went to the left of that point. So either the left of the vertex, the right of the vertex, and on the vertex, or the left of the x-intercept, the right of the x-intercept, and on the x-intercept. And that's how we've had the calculator give us those values. Okay, so for homework, I would like you to work on something that I already assigned. You already did worksheet 2, problems 5, 6, and 7, but you did them originally by hand using the algebra techniques. So now I want you to redo those problems using the graphing calculator. So it's not really something that you necessarily need to write anything else down for, as you already have all the work and answers. But what I do want you to do is do them all using the graphing calculator, and then you can check your work that you're getting from the calculator. I'm sorry, your answers that you're getting from the calculator. You can compare those to the answers that you got when you showed all the work and you did them by hand, and you should be getting the same answers. So really, I just want you to practice using the graphing calculator to answer these questions. Problems 5, 6, and 7 on worksheet number 2 in Unit 4.